Hi, fourth grade mathematicians. Thanks for tuning in for another online math lesson. Today, our learning target is that we can draw a mixed number and we can convert a mixed number to a fraction greater than a whole. We have learned that the reason a mixed number is called a mixed number is because it has a mixture of a whole number and a fraction. You're all looking at a mixed number right now. The whole number represents how many wholes, and the fraction represents what part of another whole we are working with. If I ate 2.5 Butterfinger bars, that means I ate 2.1/2 of another. On our assignment on Monday, you all did a very good job of recognizing that this was a mixed number, and you were able to identify a model or a drawing which shows that. It could be represented by something like this. That's my pizza. Splitting the pizzas in half since that's my denominator. We know that if we ate 2.5 pizzas, we ate 1, 2.5 of another. Okay, that is 2.5. We could show that as, like I said, Butterfingers or fraction bars, candy bars. That would look like this. This 2 in the denominator tells me how many parts are in each whole. So I divided each candy bar into 2 parts because the denominator is 2. I'm going to now shade in, excuse me, I'm going to shade in to show what I ate. I ate 2 whole candy bars and 1/2 of another. Okay, 2.5. We're at a point now as a mathematician where it is really important when you see a mixed number like this that you can picture either in your head or that you can draw a visual model to show what that really means. Okay? If you feel like that is fuzzy and still confusing for you, that would be a good thing to ask questions about during our Tuesday math group. Let's go on to our next step of working with mixed numbers. We need to write this mixed number as a fraction greater than a whole. That should right away say to your brain when you hear that, ding, 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 a fraction greater than a whole has a numerator, a top number, larger than a denominator. The top of the fraction, the top needs to be larger than the denominator. Here's an example, 8/2. That means that I had 8/1/2 pieces out of something. I want to show you why that's greater than a whole. Okay. If I had 8, some of you would say 2s, but the correct way to say that is 8/2. Okay. What they're saying is that I know I'm going to have candy bars again, and I'm going to split the candy bars into 2 because it's the denominator tells us there's 2 pieces in a whole. They say, well, if you needed to show 8 of those halves, how many candy bars would that be? Well, here's 1/2, 2/2 pieces. I'll shade them in, show I ate them. We ate 8/2, 1/2, 2/2, 3/2, 4/2, 5/2, 6/2, 7/2, 8/2. And I'm not saying this word. Not 8/2, half, like a fraction word, half. Or to make it plural, we know it's like this, halves. 8/2 means I have 8/1/2 units. 1, 2, 3, 4, 5, 6, 7, 8. 8/2 equals how many whole candy bars? 1 whole candy bar, 2 whole candy bars, 3 whole candy bars, 4 whole candy bars. 8 halves is 4 wholes. Okay, this is a fraction greater than a whole. Now that we understand a little bit more of what a fraction greater than a whole is, I want to direct our attention back up, okay, to what we were working with. Here's our mixed number again. We're going to constantly go back and forth. Our mixed number can be changed to a fraction greater than a whole, and here's how. If we make our model drawing, we can use that to help us. We want to know how many halves, okay, do we have here? 1, 2, that's 1 whole candy bar. 3, 4, that's 2 whole candy bars. 5, I have 5 individual half units, and we keep the denominator the same to show we have 5 what? Is it 5/3, 5/4? Oh, we have 5 halves. So therefore, 2.5 equals or is the same as 5 halves. Because inside 2.5 candy bars is 1, 2, 3, 4, 5 half pieces or 5 halves. Okay. Halves gets a little confusing because it's difficult to say. So let's look at another one. Let's do thirds. One of you has 3 brothers. We won't say names. We don't have permission, but one of you has 3 brothers. So let's do 3 and a fourth. The directions for this problem are write that mixed number as a fraction greater than a whole. We also can think of this as converting. We are going to convert 3 1/4 to a fraction greater than a whole. I'm still working with fourths, so I'm going to put my 4 there. Draw my model to help me understand what my thinking is. 3 candy bars and 1/4 of another, so I need to draw a 4th candy bar. Oof, sorry, I need to zoom out here for you. Maybe even a tad more. There we go. Each candy bar is split into how many pieces? Well, I'm working with fourths, so they must be in 4 pieces. I ate 3 candy bars. 1, 2, must be delicious. 3 and 1/4 of another. Again, what I just did is I shaded 3 and a fourth. 1, 2, 3 and a fourth. Now they want for this answer to make this a fraction greater than a whole. The question is how many of these individual little pieces, individual units, remember a unit fraction, here's 1 unit, 2 units. Well, how many of those units did I eat when I shaded them all in to represent eating of the candy bars? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I shaded in 13 individual units out of the whole, so I shaded in 13/4. 3 and 1/4 candy bars is the same as 13/4, 13 1/4 pieces. Many of your parents and grandparents know a shortcut here. We are technically not supposed to teach this shortcut anymore, but the truth is it does work, and it is a very good way to check your work. Okay, so we can use the following shortcut to check to make sure our models and our thinking is correct. Here is the shortcut. Take your denominator 4, multiply it by the whole number. Our large number is the whole number, and that's because, and that works, 4 times 3 works because you have 4 individual parts. How many times here? 4, 4, 4. You have 4 groups you have 4 3 times, or 4 groups of 3, right? 1, 2, 3, 4. Okay? And you have 3 of those groups of 4. So better to say 3 groups of 4. So sorry. Here we go, back on track. 4 times 3 works because you have 4 times 3, or another way to think of that is you have 3 groups of 4. And then we need to add that last little leftover piece here. So again, to check our work, we can use this strategy. We go clockwise. 4 times 3 is 12, plus 1 is 13. 13/4. This shortcut will work every single time you need to convert a mixed number to a fraction greater than a whole. As 4th graders, though, we need to be able to also draw this model to explain, well, why can you just take the denominator times the whole plus the numerator? The reason that that works is it's showing how many groups of the denominator do you have. We have 3 groups of 4 plus our numerator. Let's do another one. This time we'll do the shortcut first, and then I'll show you my thinking and my math reasoning with a model. Let's see, we have had 4 people have a birthday so far since we've been home learning. And let's this time work with thirds just because we haven't yet. 4, let's do a 2 in the numerator this time. 4 and 2/3. My directions say, write that as a fraction greater than a whole. I said that I'd use our shortcut first. It's denominator times the whole number plus the numerator. 3 times 4 is, hopefully you thought 12, right? 3 times 4 is 12 plus 2. You can do that in your head as mental math, but I wrote it down to show my thinking. That means my numerator is 14. That means I'm going to have 14 individual units of 3. The denominator stays the same. Now I'm going to explain. Why would eating 4 2/3 of a candy bar be the same as 14/3 of a candy bar? Let me show my candy bars and my thinking. I need 4 whole candy bars. Oh dear me. You all know that's why I don't teach art, right? Look at that crooked line. It's okay though. It's all right though. Nobody's perfect. All right. I drew 4 whole candy bars, and I know I need to shade in 2/3 of a whole nother one, so that's why I drew that next one. I'm going to look at my denominator that tells me my parts and my whole. And now I want to shade in to represent what is shown here. I ate 4 2/3. 1 candy bar, 2 candy bars, 3 candy bars, 4 candy bars, and 2 out of 3 parts of the next one. 2/3. This represents right here 2/3. Remember, we can write our fractions horizontally as well. Okay. Now, if I were to count how many individual units are found, how many 1/3 units are found in my 4 2/3, I would end up with 14 if I have done this correctly. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14/3. Okay, I can convert a mixed number to a fraction greater than a whole. Your moms, dads, maybe even older brothers and sisters, and then grandparents for sure, they used to call fractions greater than a whole improper fractions. Improper. Okay, I want to do a workbook problem with you all right now. This is left over from last week's small group learning. Okay, I'd like you to pause the video and go get your math workbooks and come back and open up to page 266. If you're here right now, we're going to do number 6 together. You must have gone and got your workbook and hit play, or you had it from the very beginning. Here we go. Let's practice number 6, 3 3/7. I'm going to write for myself up here a reminder of our shortcut. I know the shortcut says I'm going to take my denominator, my number of parts in the whole. I'm going to multiply that by my number of wholes that I have. And then I'm going to add my individual parts of what's left, okay, to get my numerator of my fraction, and my denominator stays the same. Our directions say, convert your mixed number to a fraction greater than a whole. Let's do it. Let's use our shortcut. This tells me number of parts in my whole. 7 times 3 is 21. 21 plus 3, 21, 22, 23, 24. You can write that down, 24/7. You know, you could also write it this way. Now, many of you are going to be tempted to just stop there and cruise along like it's a race, right? But remember, the more we practice, the stronger we get. It's a good idea to practice making your fraction bars for your visual models so that when we get to the test and a quiz, you're comfortable doing that. Okay, so to model that here, I'm going to be as neat as I can. I know I need 3 whole candy bars. And I know that I need another one so that I can shade in 3/7 because this mixed number means 3 and 3/7. Oh dear, I'm getting excited and drawing extras. Okay, so I have 1, 2, 3, and I'll be able to shade 3/7 out of this one. I'm going to split all of these into 7ths because my denominator is 7. That means I need 6 lines. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 lines may equal 7 parts. Let's make sure. 1, 2, 3, 4, 5, 6, 7. Yep. I tried my best to make those parts equal parts out of a whole because that's what a fraction is. I'm going to show that I ate 3 and 3/7. 1, 2, 3. And now I need 3 out of 7 of this last one, which shows my 3/7. Okay. I have 3 whole candy bars with 7 in each. So 7 times 3, which is why this works. 7 times 3 is 21 individual little pieces. In these 3, you have 21 individual pieces. And then I need to add 3 from this one. So here's 21 individual pieces plus 22, 23, 24. That's why our fraction greater than a whole answer is 24/7. You're going to be asked to try a few of these on your own today, and then we will talk about them when we get together in our small groups and play a game as well. Thank you for being good listeners. If you have questions, please have a good attitude and give it your best shot, and I'd be happy to answer those questions during our small math groups or by email. So please email if you need help. I'm here to help. Okay. Miss you all. Thank you for being great listeners and working hard.